everyone. Welcome to our channel, Professor of Pharmacy. I'll just start a new subject today, that is the physical pharmaceutics 2. Okay, so this subject is actually in the semester 4 of our B.Pharm syllabus. So, here going before to the main, the specific content or specific unit. I just will give you the little bit idea regarding the whole course content. Okay. So as you can see in the unit 1 there is colloidal dispersions, and I will just start this unit first. Okay, so after that, that is the unit 2. In under unit 2 there is rheology, and also you can see the deformation of solids, right? And unit 3 there is coarse dispersion. Okay, so under the coarse dispersion lots of the concept of suspension, emulsion, HLB scale, all those things will be there. Okay, so that is the unit 3. And after that, so in unit 4 you can see the micromatrix. Micromatrix means it is the study of the particle which are the size of micrometer. Okay, so that is the things. And in unit 5 you can see here the drug stability. The drug stability, in drug stability you will just learn about the different difference of kinetics, like the zero, pseudo zero, fast, second order, and also the what is the shelf life, and what is accelerated stability testing, this kind of thing. So now I'll just go into the first unit, that is the colloidal dispersions, because I'll start that today. Okay, so just give me some time. Yes, so colloidal dispersions. So first of all, by the term, the colloidal dispersions, here actually two terms is there. One is colloidal, the term colloids I can specifically tell, and dispersions. So I have to know, you have to know that what is colloid, what is dispersions. Colloid, I can tell that it is kind of a particle size, the heterogeneous phase of system, okay, or polyphase is like of system, where the particle size is from 1 nanometer to 1 micrometer. In a very easy or very lucid way I can tell you. And what is dispersion? Dispersion means there should be a dispersed phase, right? There should be a dispersed phase, and which is actually uniformly distributed through another phase, and that phase actually called the dispersion media, right? So give me some the time to just use the pen, so you can just see. Wait for moments. So yes, so you can see that dispersed phase is distributed uniformly throughout another phase, that is called the dispersion media. So like if I say one solution is not a heterogeneous mixtures. Here the solute and solvent you cannot just observe in a different way in from outside or in a naked eye, okay. But in the colloidal, like of any kind of dispersed system, you can observe which one is the dispersed phase, which one is dispersion media, like that, okay. So obviously dispersed phase it has little proportionality, and the dispersion media it will be in the large proportion. So that is the basic things, and so that you have to understand that what is colloids. Basically the particle size range from 1 nanometer to 1 micrometer. And what is dispersion? Dispersion means there should be a dispersed phase and one dispersion medium, also called as the continuous phase. Okay, so it is a polyphasic system, or we can say the heterogeneous phase. Okay, so that is the concept. So after that, just wait for minutes, that I will just say that how can we just classify all these things. Okay, so like dispersion medium I have already told, you have just already understood, and the particular size range, okay, from 1 nanometer to 1 micrometer you have to remember. Okay, now the classification, okay, that the classification of colloids based on the state of matter. How we can classify? Just see the table, okay. Yes, just see and observe the table. Here actually dispersed phase is given, dispersion medium is given, and types of colloid, and with respective to that particular examples also there. So what happened, if the dispersed phase is solid, okay, and the medium is also solid, so I can call it as a solid solid. Okay, like the example is colored glasses and gemstones. Got my point? So in many times and people get confused that this first medium also must be have the solution or solid liquid kind of nature. It's not like that. This first phase it can be solid, and medium also can be solid. So that's why this kind of examples like the colored glasses or salt gemstones, this kind of example you should remember for the competitive exam, okay? Because this is little bit uncommon, okay? Okay. So after that, you can also see, I mean, the example of the different of dispersed phase and dispersion medium, and their examples like the solid and liquid. If the phase is solid, okay, if the phase is solid and the medium is liquid, so then we can call it as a sol. This word or the terminology sol you can learn later also. The example is paint, snail fluids, ink, gold sol, protein. In the the chapter of rheology, in thixotropy, rheopexy, this kind of thing, you can heard this or term sol. So sol means the dispersed phase is solid and the medium is liquid. So like that, okay. Okay. So after that, also a very popular or common terminology that aerosol. There is separate chapter for aerosol, and in aerosol the phase is solid, okay, and the medium is gas. Got my point? What are the example? The example is the smoke, dust, okay, that is the common example of the aerosol. And write that the liquid solid is gel, cheese, butter, jellies, boot polish. And if the both the medium or the phase is liquid and liquid, then we call that emulsion, and the most common example is milk, you can see. And also the different kind of pumicestone, foam rubber, okay, this is the gas and solid kind of things. The solid sol we can call, and the gas liquid is called as a foam. So those are the classification based of the states of matter. Classification of which? The colloid. Okay. Okay. So this table you should just remember for the competitive exam as well as for your semester point of view also. Okay. So after that, on the basis of particle size, okay, we can just classify the different kind of dispersed system. And the particle size of what? The dispersed phase, like the molecular dispersion, colloidal dispersion, coarse dispersion. So if the particle size, I mean the dispersed phase particle size, have the size less than 1 nanometer, then we can call it as a molecular dispersion. Molecule, little bit, I mean the concept of, I mean the molecules mean the large, I mean the smallest particle, okay. So that's why 1 nanometer you can see, okay, less than 1 nanometer. But the for the colloidal, the dispersed phase have the size between 1 nanometer to 1 micrometer, and for the coarse it will be 10 to 1000 micrometer, I mean the larger particle. Got my point? And if I say the observation of visibility, so under the electron microscope also the molecular dispersion cannot be observed, because the particle size is so much small or tiny. We cannot observe through the use of any kind of microscope also. Got my point? But still, by the use of any kind of same scanning electron microscope, any kind of high resolution power, which have the high resolution power, we can little bit I mean the demonstrate or invisible I mean the view or observe this kind of dispersion, but still it is invisible, okay. But for the colloidal dispersion, with the help of ordinary microscope, I mean the compound microscope, we cannot resolve, we cannot observe. But with the help of any kind of scanning electron microscope, we can observe the colloidal dispersions. Got my point? And the coarse dispersion, it is also, but the coarse dispersion, the particle size is larger, so we can observe easily by the help of any kind of compound microscope, okay. So that is the point, that under which microscope which one is visible, which one is not visible, you should remember this kind of concept, right? So after that, I mean the semi-permeable membrane and the ultrafilter, this kind of concept is there. I mean throughout this kind of ultrafilter or semi-permeable membrane, which kind of dispersion is easily passed, can pass or cannot pass, this kind of thing you should remember. Like molecular dispersion, the particle size is so small, okay, like the smallest particle size. So that's why it can easily pass through any kind of ultrafilter or semi-permeable membrane, because the particle size is less than 1 nanometer. But if I say the colloidal, it do not pass through any kind of semi-permeable membrane, it but can pass through the filter paper. Okay, you should remember this point. It do not pass through the semi-permeable membrane, can pass through the filter paper. But the coarse dispersion, it doesn't. I mean, the do not pass through any kind of normal filter paper or any kind of semi-permeable membrane. It cannot pass because the particle size is larger. So it will got stuck in this kind of membrane. Okay, so that is the point. And from diffusion point of view, what is diffusion? Diffusion means for any kind of concentrated particle, concentration area to give the go to the lower concentration. This kind of concept is actually diffusion. So undergo rapid diffusion, the molecular dispersion, they actually undergo rapid diffusion. But if I say the colloidal dispersion, the diffusion is very the slowly in process, but coarse dispersion doesn't diffuse. That is the point. And last one, the example. From any point of exam point of view, like competitive or semester MCQ, you should remember all this kind of point. The example, like the glucose. Glucose is example of molecular dispersion. Okay, oxygen molecule, glucose, this kind of thing. Okay, mainly the glucose, it is actually very much important example of any kind of molecular dispersion. But for colloidal dispersions, okay, for colloidal dispersion, the example is silver solution, natural or any kind of synthetic polymers, cheese, butter, cream. So polymers may be like of xanthan gum. Okay, the natural polymers also like a gum, tara gum, these kind of things. Okay, and coarse dispersion, the very important, the example, the suspension of RBC, red blood cells. People might get confused that red blood cells is a kind of molecular dispersions, but it's not like that. Okay, it is the example of coarse dispersion. The particle size of that particular red blood cell is under the size of 10 to 1000 micrometers. So suspension of RBC. Okay, so you should remember this entire table, that on the basis of particle size, how can we classify different kind of dispersed system. Okay, so all those example and the particle size, I have already underlined all those things. Okay, so you should remember. So after that, I will just give you some idea. Just wait for some moments, that I will just give you some idea regarding the property, okay, the characteristic. Just wait for some moments. Just give me some time. Yes, the characteristic of the dispersed phase, right? The based on different of property or characteristics, our dispersed medium and all the, or we can say the colloidal dispersion, it have whole different of property or characteristics, like the color, viscosity, all those things. Okay, the color of that particular colloidal dispersion, the viscosity, it can be depends upon this kind of phenomenon, size, shape, area, charges. Okay, so how they can actually affect or they can influence this kind of color, viscosity, I'll just discuss one by one. So first one is the particle size. So see here, the particle size, they can influence the color of the dispersion. The important point is that the color of the dispersion can be depends upon this kind of particle size. How? Now the wavelength. Obviously, any color, it's actually the light of any kind of transmitted light. We can just call it as a color of that any kind of particular object or substance. So the wavelength of any kind of light absorbed by the particle approximately related to this radius, means you can see the next line, and you can understand it's very clear. The larger the particle size, obviously the radius will be high, so shorter the wavelength, it will transmit it. Okay, got my point? The larger the particle size, the shorter the wavelength of light, it will transmit it. Means obviously one subject, it can absorb some light, and after that the light, it actually transmitted. So one observer actually observe that particular object in that light only. If the color of any kind of object is violet, means it actually transmitted the violet ray towards our eyes. Okay, so that's kind of thing. So for the larger particle, the shorter wavelength light will be transmitted, that is the violet color, because from the tricks VGO or short terms, we can know that violet have the shorter wavelength. And the next example, you can observe also, the very in a tricky way, this is written that the colloidal gold has a red color. So what actually it signifies? Means the colloidal gold has a smaller particle size. So as the particle size is smaller, so it will transmitted the longer wavelength. Okay, because the red color or the red light have the longer wavelength, 650 to 750 nanometer. So that is the point. The larger particle, it will transmit the shorter wavelength, and the smaller particle, that will transmit the longer wavelength. So that is the relation with the particle size and the color of that particular dispersion. Okay, so you should remember all those things that I have already underlined, that particular point. Okay, so after that, just wait for some more, the particle shape. So how can the particle shape also can impact or can affect these kind of things? Particle shape also, just wait from some moments, that particle shape also can depend, I mean affect this kind of color. Got my point? Particle shape also can affect the color and also the viscosity. How? I mean the spherical particle, like you can see here, the spherical particles of gold, okay, shape also influence the color. How? The spherical particle of the gold is indicated by red color. Got my point? The spherical particle gold is indicated by red color. I mean, if the shape is sphere, then it will transmitted the red color. But if the shape is like a disc nature, then will transmitted the blue color. Got my point? That how the shape can influence the color of any kind of dispersion medium. So you can see the example. Okay, for the spherical gold and the disc like particles of gold. Okay, and also the viscosity concept is also there. If the particle shape is spherical, then the viscosity will be low. Okay, means a low viscous dispersion will be there. In the dispersed phase have the particle shape of sphere, so then the viscosity will be low, because the friction between the any kind of solution or the liquid particular medium will be low with it, I mean the corresponding surface area. So the viscosity will be low, but if the linear particles is there, so it will produce the viscous dispersion, means the viscosity will be high. So that's the way, that's the method that one particle shape also can influence the color and viscosity. So next one is the surface area. So how can surface area can impact? So first of all, you have to understand the surface area of any colloids, it have more than any kind of coarser particle. So that's the line is actually written here. The size of the colloidal particle is of order of few micrometers. This particle poses the enormous surface area when compared with the coarser particle. Means if I compare any kind of colloidal substance with a coarse substance, the surface area will be more for the colloidal particles. Why? Because the particle size obviously is a one point, and the dispersed phase as it is, I mean the uniformly distributed. So that's why if it have the sphere, so obviously surface area will be more, and the larger surface will be enhance the solubility of the drug particles. This is the point. Okay, the larger surface area will enhance the solubility of the drug particles. And last one is the stability. So you have to only particularly identify the stability. I mean the surface charge, it actually affects the stability of any kind of colloids. Not only colloids, the surface charge actually affect the stability of any kind of emulsion, suspension, all those kind of things. But our discussion will be here only in colloids. So what happened? I can give you a brief idea that in the dispersed phase, if the particle charge is positive and medium the charge is negative, so obviously the alike charges will be there. So there is an attraction. But if the charges is like the positive or negative for both the cases of dispersed phase and the medium, so obviously there will be repulsion. Repulsion means there is a high chance of instability. Got my point? So that's the actually things you should remember. The surface charge actually influence or impact on the stability of any kind of colloids. Okay. So here the line also the written there. The particle move continuously in a random manner. So that's why I mean the little bit concept of Brownian movement you can tell. So due to that the collisions is happen. So then due to that also the charge may be I mean the produced in any kind of dispersed phase or medium, and after that if the charge is like charges, then the particle create or they can experience the repulsion force, and the repulsion force means there is a chance of instability. So you should remember this kind of concept, that how can the surface charge can affect this kind of stability of colloids. Okay, so these are the point that I have already discussed, that how can this particle size, particle shape, surface area, charge can affect the dispersed phase or any kind of medium. Okay. So after that, I will give you the little bit idea regarding the classification of colloids. Classification of colloids can be, I mean, depending on different. So now, depending upon the solvent system, how can we classify the colloid? See, here one terminology is lyophilic, lyophobic. So don't get confused with the term lipophilic with the lyophilic, because it is completely different or separate thing. Lipo means lipid, but lyo means solvent. Lyo means solvent. So lyophilic colloids means the particular colloids which have the affinity or loving towards the solvent system. Got my point? So you should just careful regarding this kind of things. The lyophilic need means not the lipophilic. Lipophilic means the lipid lover, but the lyophilic means the colloids which have the loving or the affinity towards the solvent. So I like this way only. Lyophobic means obviously that one heading will be there, okay, with the any kind of solvent system. And association colloids is kind of surfactant, you can tell. The association colloids is a kind of surfactant, surface active agents, okay. Amphiphilic colloids we can tell. So now I'll just give you the total description, like what are the comparison between the three different types of colloids like lyophilic, lyophobic and association, okay. So here you can see that lyophilic, obviously from chemical point of view, if I say, they are the organic molecules and they have the loving or affinity towards the solvent system. Lyo means solvent and philic means loving. But whereas the lyophobic, they are just inorganic in nature and they have the heading towards the solvent system. Solvent heading colloids, okay. And association colloids, I have already told, this is a kind of the surface active agents or aggregation of the surface active agent. If you can see any kind of micelle formation, okay, micelle means the aggregation of the surface active agent, okay, above the CMC or equal to the critical micelle concentration, that concept. So this is a kind of that thing, the aggregation of surface active agent, that is the amphiphilic. And now from the point of view of the interaction, then which interaction force is higher for which colloids? Like obviously lyophilic colloids, they have the interactions are stronger between the both page because the solvent have the affinity towards the colloids. But if I say the lyophobic, interaction will be little because there is a heading or affinity is less, okay. And for the association colloids, they are the aggregates particles like surfactant, okay. Okay, now in the solvated the charged particle, like in the lyophilic they less charged but solvated, but the lyophobic the charge is high, and the association colloid they just charged micelle but solvated. Means if I consider the charged particle means positive and negative different charge I have told, but as it is a solvent lover, so it is obviously easily, what I can say, dispersed or easily the spread throughout the medium. So the charge is there, but the amount of charges is very less because the random movement is less here. Because earlier I have discussed that if the movement of any kind of particular dispersed phase is high, so there they might be obtain a little bit charge. So in lyophilic, so the compared to the lyophobic, the charge is less. That's why, okay. And from thermodynamic point of view, as it is the loving towards the solvent, so there is a thermodynamically stable properties there. And in phobic cases, the thermodynamic instability is there because it is very difficult to prepare, okay. Because very difficult to prepare, and aggregates of the surfactant, they are the association colloids, they are also thermodynamically stable, okay. So this is the case, and stable in presence of electrolytes, and CMC reduced for the lyophilic, and the CMC concept and the critical micelle concentration. So here only one term is the dispersed phase is addition. The viscosity of the dispersion medium is increased with the addition of the dispersed phase. That is also one important point you should keep in your mind, okay. For the lyophilic colloids, viscosity may be increased by the addition of the dispersed phase, okay. Why? Because if the dispersed phase is more, obviously the interaction force will be more, the friction will be more. So by that way, by that mechanism, the viscosity may be the high, okay. So that is the concept. And which one is reversible? The lyophilic is reversible. That is irreversible means we cannot just convert it through different of way. If it is converted from lyophilic to lyophobic, it is not irreversible. It cannot be just get the lyophilic again. So that kind of concept. And the example you should remember, like the rubber and polystyrene, those are the example lyophilic, and lyophobic are the gold, silver, sulfur, this kind of thing. And association colloids are the surface surfactant, okay, normal surfactant I can take. So those are the things actually I should discuss in first class, okay. So you should remember, for which cases the viscosity is high in addition of this kind of things, you should remember, okay. So now, so I will just discuss the in next class the different kind of properties of the colloids, like the optical properties, kinetic properties, electrical properties. Okay, basically I will just go with the one by one, like the optical properties. So today I will not start this kind of things. In the next class I will start. So if you have any kind of doubt, you can just ask in the comment section. Okay, so that is from my side. Okay, thank you.